96 million barrels of oil each day to power industry, agriculture, transportation, heating, and much more, but oil is a finite resource and an expensive commodity. To slow down the catastrophic impact that running out of oil will have, many countries across the world have policies requiring blending traditional oil with biofuels. But what are biofuels?
We can create clean, renewable transportation fuels from plants, trees, and a range of other organic materials. In other words, biomass. Okay, so biomass is organic material from forest thinnings and wastes, from crops grown to produce energy, and from other renewable energy sources like algae that can all be converted into fuels.
Canada embraced biofuel production wholeheartedly as part of its strategy to significantly reduce Canada's greenhouse gas emissions. To implement the program, Canadian government could have used a 6-step strategic management process. Step 1 is identify current visions and goals. Canada's goal is to reduce 17% of its CO2 emissions by 2020. Step 2 and 3 are internal and external analysis, also known as a SWOT analysis. Biofuels reduce greenhouse gas emissions, increase energy security, and reduce dependency on foreign oil. However, biofuels are land-intensive, have lower energy content per volume than fossil fuels, and grain production is vulnerable to weather conditions. In terms of opportunities, biofuels can replace a percentage of fossil fuels and can decrease dependency on crude oil. However, grain production for biofuels might affect food prices. Additionally, the biofuel market is comparatively new and has a small share of the fuel market. Step 4 is formulate strategies. The Renewable Fuel Regulations was published in 2010 and requires 5% renewable content in gasoline and 2% renewable content in diesel fuel. Step 5 is implementation, and Step 6 is evaluation. Economically, the program has reduced greenhouse gas emissions by 3 million tons of CO2 emissions per year, but at a cost of $180 per ton. How about its environmental impact?
But the balance sheet is not always so positive. While the CO2 bound by the rapeseed plant gets released again when the biofuel is burnt, it can simply be bound once more by newly planted rapeseed. But how much additional greenhouse gas is released during the process of producing biofuels is heavily dependent on where it's produced and the techniques employed. If a lot of artificial fertilizer is used, for example, the greenhouse gas equation will not be so good. It will even be negative if ecologically valuable land is destroyed to make way for biofuels, for example when rainforest is turned over to cultivation.
Does this mean the final nail in the coffin for biofuels? Not quite. There are still other feasible options out there that don't have the cost of regular biofuels, both monetary and environmentally.
Recycled vegetable oil reduces carbon emission by 90% compared to conventional diesel. This works out to saving about 90.6 pounds of CO2 per gallon of biodiesel. And because it's a waste product, there is minimum carbon footprints from its production. Currently, the Capital Regional District have a recycling program where residents can drop up to 10 liters of cooking oil to be converted to soap, animal feed, or cosmetic. However, about 1 million kilograms of waste oil are poured down to drain annually in the CRD. If all of that was recycled into fuel, it could produce over 280,000 gallons of biodiesel. For comparison, BC Transit estimates it uses approximately 23 liters of fuel every year. In the home, cooking oil can be tuned into biodiesel for domestic use, using no more than oil, lye, methanol hydrate, and a glass blender. Are there any standards in place in terms of production of biofuels? Biofuels producers need to follow certain standards in order to be certified as such. Let's see how such standards are applied in case of Germany.
A producer wanting to provide evidence of sustainability must also produce in a socially sustainable fashion. In Germany, there are already standards, in the production of biodiesel, for example, designed to ensure the health and safety of employees. Some certification systems demand unambiguous compliance with social criteria on the part of manufacturers, including those based abroad. The latter must now also be able to show that they are producing in a socially sustainable manner if they wish to export to Germany.
Reliance on biodiesel has its controversies, but because biodiesel can be easily stored and transported compared to wind and solar energy, it is still a piece of puzzle towards creating renewable energy.